welcome to the July Novice meeting of the Houston Astronomical Society. My name is Chris Morisette. I'm the Novice Chairman, and I want to welcome you to Gems of the Summer Sky. We talked a little bit about this a couple of months ago about why the Milky Way gets brighter during this time of year, and we'll kind of review that as well. But this is a picture from last summer out near Marfa that I took, so I thought that would be kind of a great way to start off this summer tour. So what we'll do tonight, which is consistent with our quarterly talks on the night sky, we'll just go through and do a little bit of navigating the sky, have a quick refresher. We'll then talk about the summer signposts that we can use to find our way around the summer sky. We'll then go on a tour. We got some really wonderful objects that are out there for viewing. And then I'll wrap up with some announcements. Tonight's program should be shorter typically than what we typically have. So, given that we've got a big holiday weekend coming up, I'll be able to cut you guys loose earlier. So, navigating the sky, just a quick refresher. Y'all know me and my love affair with skymaps.com. Again, if you're new to the hobby, this is a great resource. You just go into Google, type in sky maps, all one word, hit enter, go to their website, and you can get downloads, free downloads of the maps that we have for the various months of the year. Because as you may or may not know, our skies change as we orbit the sun. So this is the sky map that we have for July. And what you would do is you would print this out and you would take this outside and you would get a compass maybe on your phone or a handheld compass, and you would point to the south and you would face south, and you would, in that situation, point the paper so that the word south down here is pointing down towards the ground. And when you do that, what you're able to see are the various constellations and asterisms that show up that will be in front of you as you're looking up into the night sky. If you turn around 180 degrees and face north, you would take the map, turn it upside down so that the word north is pointing downward, and then here is what you would see in the north sky. So you would see here Polaris, and you would see the Big Dipper, and that's how you use this map. We use the celestial sphere as our model to kind of help us find our way around the night sky. So the celestial sphere is nothing but a kind of a parallel shell, if you will, around our own Earth. So the celestial equator, the celestial north and south poles mirror our own equator and our own north and south pole. There are also a coordinate system here called right ascension, which is what you see right here, and declination, which is what you see right here. And those coordinates are fixed for any star, nebula, galaxy, any object that you would see in the night sky, except for our own planets in the solar system. But that coordinate system is fixed, and it's analogous to right ascension is analogous to longitude, and declination is analogous to latitude. And it's this coordinate system that, again, helps us anchor certain points in the cosmos. There's another imaginary oval that's out there that kind of sits on the face of the interior of our celestial sphere called the ecliptic. And the ecliptic is at a 23 degree angle to our own Earth. And this is where you're going to find the sun, the moon, and the planets. And it's at a 23-degree angle because our Earth is tilted 23 degrees relative to the sun. The ecliptic, as you can see here, is in red. Also is where you'll find the constellations of the zodiac. So if you're familiar with the zodiac at all, you can add 12 constellations to your database of constellations by knowing that we've got constellations like Gemini, Taurus, Virgo, Scorpius, and Aquarius, uh, Pisces. Um, all of those particular zodiac signs are in fact constellations that reside on the ecliptic. There is an additional one called Ophiuchus, the 13th, kind of like the fifth beetle. Um, that constellation is not in the zodiac, but it does reside on the ecliptic. And I'm dating myself when I said fifth beetle, so forgive me. Here is another view of the celestial sphere where we have the celestial equator and the ecliptic plane. And I've also added in here the galactic equator, which sits at about a 63-degree angle relative to the Earth. And I included that because the Milky Way is very prominent, very bright, very brilliant, and this kind of gives you an idea of, how it shows up in our own night sky. This next picture here is one that I really love. It's kind of taking you out of that sphere and putting you out into the cosmos and kind of viewing our solar system and our Milky Way to kind of see um, what's happening out here. So here's where we were in the springtime. We were up at this point in our orbit around the sun, and we were in springtime, and we were pointing towards the thinner part of the galactic disk out into the wide open cosmos where we could see all kinds of galaxies. And that's why springtime gets its nickname, the galaxy season. We are now over here, and what we are able to do during the nighttime is we are facing back towards the center of the Milky Way, and the center of the Milky Way appears to us to be so bright during this time of year because there's a high density of stars that we're looking back into as we look back into the core. So we get a lot of brightness, a lot of luminosity, and that's why the Milky Way looks so cool during this particular time of year. We can also see it during the winter, but it's much more faint and it's not as cool to look at as it is this time of year. Another thing that is really an important concept is the whole idea of your position on Earth and your latitude on Earth. That will dictate the degree of altitude that Polaris has above the horizon. So, at an extreme, if I'm at the North Pole, Polaris will be at a 90-degree angle. It'll be straight above my head, and the sky will turn around me as I'm standing up there. As you move farther south, Polaris lowers itself um, in its altitude above the horizon. So here is approximately, let's just call it Houston. We're at 30 degrees north, so Polaris will appear to be at 30 degrees above the horizon. If we go to um, Chicago or Seattle, which is probably closer to 40, 45 degrees, then we would need to look up higher in the sky to see Polaris. If we go down towards the southern hemisphere and actually cross the equator, we'll get to a point where we won't see Polaris at all. As a matter of fact, when I was in Australia in April, I was doing the bridge tour, and one of the participants on the tour was a guy from Austin, and he was a sailor, and we're standing out there high above the traffic over Sydney. It was a beautiful night. And he goes, "Hey, where can I find Polaris here?" And I said, "Well, it's not visible." And he was kind of taken aback by that. But that's true. We can't determine or find Polaris once we get at a point below the equator. Rules of thumb. So, I love the handheld apps. I think they're wonderful tools. But you will get to a point where you'll want to kind of test your knowledge of being able to go out and read the night sky without the aid of an app. At least I hope you are. And when you get to that point, you want to find distances. You can use your hand and the widths of your fingers in order to determine distances. And as the chart shows, for example, if I put up three fingers, the width of those three fingers is going to be 5 degrees, fists 10 degrees, so on and so forth. So you can use your hand and you would place your hand at arm's length and use that as a measuring device. Okay, so a little bit on just kind of some of the navigation basics. Let's move on to signposts. Um, so this map that you see right here shows all of the signposts that we have available to us throughout the year. And you can see over here that we could use Cassiopeia in the autumn. We could use Orion in the winter. The Big Dipper and Arcturus and Spica were very prominent during the springtime. Now that we are in the summertime, we have some more signposts that we can add to our toolkit. So the Keystone, which is in the constellation of Hercules, that is a asterism we can use as a signpost. The Summer Triangle is another, and probably the main signpost that we use during the summertime. And then if we have a open enough horizon, we can use the Teapot, which is down here. And we'll talk more about how we can use those what constitutes those signposts and how we can use those. Okay. The Big Dipper still is useful to us. You'll see here in the springtime, it's very high up in the sky during the nighttime. Oh, one other thing that I just need to point out, this green box that I show up here, um, I put that on here to denote kind of that prime time view that we have of the night sky during the summertime. It's an approximation, but it gives you an idea of what part of the night sky we can see kind of in that 9 o'clock to midnight period of time. If you stay up late enough, you will begin to see um, objects and signposts that are farther to the left over here. And a really cool example of this is Orion. Um, if you are up early, and I'm talking about, 4:30, 5 o'clock in the morning during August, you will see Orion coming up over the horizon and you can view it for maybe 30, 35 minutes, and then pretty soon the sun will rise and we will lose our view of the of Orion because the brightness will obscure it. But that is kind of a key thing to remember is that if you stay up late enough, you can see more than what I've got highlighted in this green box. But the green box is kind of our main area of interest. So that's the only point I wanted to make there. The Big Dipper. So back to the Big Dipper. During the springtime, it is very high up in the sky, which makes it very useful as a signpost. In the summertime, it still is high up in the sky as well, so we can still take advantage of it. In the autumn and the winter, though, we really can't because it rides pretty close to the horizon during the nighttime. So we can't really utilize it during autumn and winter time. However, we can during the summer, and the way we use the Big Dipper is or one of the ways we can use it is by going off of the handle here of the Big Dipper and arcing to Arcturus and then speeding on to Spica. And we'll utilize this part of the signpost for our talk tonight. There are other ways to find other objects that we talked about in the spring sky tour, but we'll focus in on the Arcturus Spica piece of the signpost tonight. Okay, so with that, we'll get into the summer objects. So let's talk a little bit more about our signposts. So we talked about the Big Dipper, Arcturus, Spica, talked about the Keystone here, and then I kind of gave short shrift to the Summer Triangle, which is really an important signpost for us. And This signpost is made up of three stars, three very bright stars that you can um, easily find in the night sky. And the first one that I'll point to is Vega. It's in the constellation of Lyra. If you drop a line from there over to Deneb, which is the tail of Cygnus the Swan, you've got one side of the triangle. You go from Deneb down to this other bright star called Altair in Aquila. That is the third point on the triangle, and then a line from Altair back up to Vega will complete the triangle. So these three stars are the three bright, distinct stars that we use. Now, when you're first starting out, it's not as obvious as Orion is in the winter because it's kind of up over your head, and there's only three stars that we're talking about. However, with a little practice using your phone app, you shouldn't have any trouble finding these. And then once you do, it'll become second nature to you. But the summer triangle is an important signpost for us. And you'll notice also that the stars in the summer triangle actually reside in three different constellations. So it's a little bit different than, say, Orion, for example. The next signpost that we've got down here is the Teapot, which is in Sagittarius. And I've got some other illustrations that show that more clearly. This one's a little bit jumbled up right now, but the Teapot is another one that we'll take advantage of, and it's got some really cool objects around it. So the first object that we're going to go to is M13, which is a globular cluster in the constellation of Hercules. And M13 is, in order to find it, what you would do is you would find Arcturus, which we can do by arcing to Arcturus off of the Big Dipper handle. And then what we can do is from Arcturus, we can go up towards Vega, which is one of the stars on the summer triangle, or we could find the Keystone. Either way, this is one way to find it, though. But this is about um, two-thirds of the way from Arcturus to Vega is M13. And again, it's a globular cluster. And here's a nice picture of M13. It is about 23,000 light years away from Earth. It is about 145 light years in size, and it contains several hundred thousand stars. It's about 12 billion years old, so it is almost the age of our universe. These globular clusters are very ancient objects, and there's theories around the nature of these objects being perhaps an old galaxy that got torn apart, and this is a remnant of an old galaxy, so on and so forth. But regardless, they're beautiful objects to look at. You'll notice also the distances are relatively large compared to, say, a distance we would have from Earth to, say, Orion, M42. Uh, Instead of being about 1,900 light years, it's 23,000. And one of the reasons for that is these globular clusters actually reside up in the halo of our own galaxy. They are gravitationally bound to the Milky Way, but they will orbit and can orbit up into the halo. So they're actually up above or below the galactic plane, which I think is pretty interesting. So that's M13, and that'll be one of two or three globular clusters we'll talk about tonight. Here is the summer triangle. And the summer triangle, just by itself, has a lot of interesting objects. And we're going to cover about three of those objects here tonight. There are some additional objects that we'll cover during our autumn tour. So we'll be coming back to the summer triangle. But it's really got some really neat stuff. And again, just to kind of recap, here is Deneb, which is the tail of Cygnus the Swan. Down here you have Altair, which is in Aquila. And then up here you have Vega, which is in Lyra. Okay. Now, the first object that we're going to look at here is Alburio. And Alburio is actually the head of Cygnus the Swan. So if I go back up here, We're really just talking about this star right here. So if you can find Deneb, you can make out Cygnus the Swan. It's a relatively easy constellation to find, even in light polluted skies. And once you get to that point, you can find this right here. Now, this is, I'll be honest with you, this is not um, an easy object to find in urban or suburban light polluted skies. Out at the dark side, it would be relatively easy to find. But once you do find it, you'll see a double star and these two stars that make up the head of Cygnus the Swan are indigo and gold in color. So you get some really neat colors if you're able to find this double star. It's about 430 light years away, so it's relatively close to Earth. And again, this is a great one to start if you're just starting out doing visual astronomy. This is really a good object to go after because it's relatively easy to find. And once you find it, um, you can tell right away that you're on the right stars by looking at the color and finding or determining that they are in fact a double star. So Alburio is kind of an easy one to put on your list to go after. That's the thing I wanted the point I wanted to make there. And I'm just going to grab a quick sip here. Thank you. Now, next we're going to move on to the Ring Nebula. Now, the Ring Nebula is a real favorite. Um, this is about 7 degrees from Vega. Okay, so if we go back up to our map, if we find our summer triangle and we find Vega, we are right there for the Ring Nebula. And the Ring Nebula is about 1,400 light years away from Earth, and it's less than a light year in size. It's about a half a light year in size, so it's a very small, very faint object. Now, this is a planetary nebula, and for those of you that are new to the hobby, a planetary nebula is actually the remnant of a star that has consumed all its fuel, has collapsed into a white dwarf, and it shed off the layers of gas and dust. So for a very large star, you have a supernova, which results in a cataclysmic implosion. Here, it just kind of dies with a whimper. The star collapses, the gas and dust is shed off. And because the white dwarf, although not burning or consuming fuel, is still very hot, kind of like a campfire, glowing ember of a campfire, it's still producing a lot of radiation that illuminates uh, the material that was shed from the surface of the planetary nebula. This is an object that you will need uh, a telescope to see. I have seen this successfully through Dobsonian telescopes of 8 to 10 inch in diameter. So that's the kind of magnification that you're going to need. And the thing also, when you find this object and you're looking at it naked eye, you're going to see what appears to be kind of a grayish smoke ring. So you won't see these brilliant colors that you see here. Instead, you're going to see a grayish tone or hue. So be prepared for that. You will be able to see the details. In other words, you'll know you're looking at the Ring Nebula, even though it's grayish and black in color, but it won't have the color that you see here. But it is a great object to go after. It's cool to see. You'll know right away that you're looking at it. And again, if you go out to like prime night, hopefully we have good weather for that here coming up in the middle of July. You'll be able to maybe hitch a ride on somebody's telescope and take a look at it. So that is the Ring Nebula, and that's near Lyra. Next, we're going to go to another planetary nebula called the Dumbbell Nebula. And this is about 15 degrees from Altair, about 25 degrees from Deneb. So if you get to your summer triangle and you find Deneb and Altair, it's about 3/4 of the way from Deneb down to Altair. So that's how you can use the summer triangle to find this. Um, Again, this is a object that's about 1,400 light years away, and it's very small in size, about 3 light years in size. And it's actually in a constellation called Vulpecula. So it is a constellation that sits between Cygnus and Aquila. And what this object, it's a beautiful object to look at. And again, you're going to have kind of the same experience if you're looking at it through a Dobbs telescope. It's going to look grayish, it's going to look smoky, it won't have the color, but it will have the shape and the pattern. So kind of keep that in mind. The other thing that's really interesting to note here is there are, multitudes of planetary nebulas out in the heavens. You'll notice they have different shapes. And, there's some things the factors that can kind of cause that to happen. And number one would be, the way we're looking at it. So our view of the nebula, kind of like when we look at a galaxy and we look at it face on, we see the entire galaxy. As some galaxies we're looking edge on. You kind of get the same thing here. The other thing too is that, no two stars are alike. So when they die, they're going to die in different ways, shed the gas and dust in different ways, and as a result have produce different patterns. You'll also have other objects in the vicinity in the neighborhood that will affect the way the gas expands out from the white dwarf. So there are a number of things that contribute to the shape and the coloration of these, and that's why it's kind of cool because each planetary nebula, no two are the same. They'll kind of have their own distinct fingerprint. So that is the Dumbbell Nebula. Okay, so now so that was up in the Summer Triangle. And again, that's a great thing about the Summer Triangle. Once you find the Summer Triangle, you're right in the neighborhood of some really great objects. We're now going to go down to the Teapot, which is down here. And the way we'll get to the Teapot is by drawing a line from Deneb to Altair and then just following that line roughly at the same angle down towards the horizon, and then that's where we'll get to the teapot. Now, the teapot takes a relatively low horizon. I certainly have trouble seeing it. I have seen it here in Kingwood out my front door, but it's kind of relies on it coming up in a keyhole, so to speak, between all the tall trees around here. So it is accessible, but it's not accessible for very long. If you're out at the dark side, you'll get a wonderful view of the teapot, a long view of the teapot. So that is a great thing about our dark side. It allows you to see those objects uh, because you've got that low tree line. But this is what the teapot looks like. It's got a lid right here. It's got a spout, body of the teapot, and then the handle. And then we're going to use that teapot to find some really cool objects. And the first two that we're going to go to are the Lagoon Nebula and its neighbor, the Trifid Nebula. And we would do that by coming up off the spout of the teapot and going up about 8 degrees above the spout. And when we do that, we come into view of these two magnificent nebula that are out there. So this is the Lagoon Nebula that you see right here. Um, it is about 4,300 light years away and about 144 light years in size, and it's located in Sagittarius. M8 is faintly visible to the naked eye, and it's one of two star-forming regions that we can see with the naked eye, the other one being M42. Um, I think when you go out and you look for this, especially in the Houston area, you're going to probably need binoculars. Um, However, at the dark site, you probably will be able to see this naked eye. Now, I'm going to be out in West Texas next week, and I'm doing one of the Astronomical League challenges where you're using binoculars to find the Messier objects. So I'm going to use those to find this, but I'm going to see if I can find this one naked eye. So I'm really kind of looking forward to seeing if I can pull that one off. M20 is this nebula over here, and this is a really interesting critter over here because it contains an emission nebula, and Lagoon Nebula is an emission nebula. But here you have an emission nebula that is part of the Trifid Nebula. You have these dark creases here, which are dark nebulosity. And then over here, you have this blue, which is actually a reflection nebula. You also have a star cluster that's in the middle of this thing as well. So the cool thing about the Trifid Nebula is you get three different nebula types all in one frame, one field of view. So that is the Trifid Nebula. And photographers, the other great thing about these two nebula is that they're close enough together that if you get your field of view right, you can get both of these in one frame. So that's pretty neat. The next one we're going to go up to is the Swan Nebula, M17. And this one is about 10 degrees above the Teapot lid. So if I come back up here to, this is where we're measuring from. This is up about 10 degrees from there. That's where we're going to find the Swan Nebula, which is what you see right here. This nebula is another emission nebula. It's 4,200 light years away, about 57 light years in size, and it's also located in the constellation of Sagittarius. There's a really bright region in here, which is due to a lot of star activity. This is a star breeding area, and you have a lot of emission coming off of these new stars that are being formed. So that's kind of what's going on here, and that's the Swan Nebula. The next one on our list is M16, which is the Eagle Nebula. Now, this is a really cool nebula. This is about 12 degrees above the Teapot lid, so it is right in the same vicinity as the Swan Nebula. It's about 5,700 light years away, about 58 light years in size. And this is, again, an emission nebula that is in the constellation of Serpens Cauda. Now, the cool thing about this one, and you can make it out from this picture, this is the nebula that has the pillars of creation, which is what you see right here. Those little spiked areas that you see right here and here. Now, if you're at all familiar with some of the Hubble photography that they did early on, they did some really awesome, magnificent images of the pillars of creation. And although this is not nearly as dramatic as those, you can still make these out. So if you're an amateur astrophotographer, you can capture the pillars of creation, and it's really kind of a neat thing to do. These clouds consist mostly of hydrogen and traces of gases and dust. And again, a very cool nebula to find. Another one that's on my list. I don't know if I'll be able to see them with binoculars, but I'm going to give it a try and see how much of this I can make out. But that is the Eagle Nebula M16. Okay. Next, we're going to move on to Antares, and you'll notice I can get to Antares a couple of different ways. Here I show how you can use the Keystone to find Antares, or I can kind of go to the right from the Teapot. To be honest with you, Antares is a very distinct orange star, and you can't miss it. So if you could find the Teapot, you definitely can find Antares because it is a very distinctive orange color, and it's so bright that even here in light polluted Kingwood, I can find it very easily if it's between the trees. Okay. Here are three objects that we're going to talk about in near Antares. We're going to talk about these two open clusters over here called M6 and M7. And then we've got another globular cluster that's right next to Antares. So the first two that we're going to talk about are M6 and M7, and those appear right off of the tail of Scorpius. next to a star called Shaula. So if you find Antares and find the pattern of stars down here and make out the tail, you'll be able to find these two open star clusters right here and here. And then this is a different picture that just kind of provides a little bit more detail on how to find these objects. Here is a picture that shows you M7. Let me make sure I'm not lying to you. That's M7 down here and M6 up here. So a little bit about these clusters. Um, these are both within about 5 degrees of the tail of Scorpius. On average, they're about 1,200 light years away from Earth. Their size, M7 is about 23 light years in size. M6 is 9 light years in size. But because they're so close, we have a wide field of view, or a decent field of view, if you will, in terms of finding these. They are open star clusters in Scorpius. M6 or M7, excuse me, was first mentioned by Ptolemy back in 130 AD, and he called this the little cloud that was following the stinger of Scorpius. And then up here is M6, and M6 has one of these really bright orange supergiant stars. I think it's this one right here. And the reason I mention that is because open star clusters can be difficult to tell whether or not you're looking at the star cluster in question. In other words, there's so many stars up there in the cosmos. Sometimes it gets a little confusing. However, if you remember with M6 that there's an orange supergiant, you can use that feature as a marker to tell, hey, I'm looking at the right thing. I'm looking at the right pattern of stars over here. So, just kind of a tip for observing star clusters. I think you've heard this story from me more than once. They are a difficult object for me to find because, again, I have a hard time distinguishing the star cluster stars from their surroundings. It takes a lot of practice and a lot of skill in order to, I think, really get good at that. But these are two that are worth trying. I'm going to certainly give it a try next week when I'm out in West Texas. So I'm pretty excited about that. M4 is that globular cluster, and it's basically about a degree from Arcturus. So if you find Arcturus, or not Arcturus, from Antares, excuse me. So if you find Antares, then you're right in the ballpark. If you got a pair of binoculars or even like a 6-inch diameter Dobbs, you're going to probably, if you find Antares, you're probably going to have that object in your field of view. So that's the way to find M4 is to find Antares. This particular globular cluster is 7,200 light years away. It's 75 light years in size, so it's going to have a relatively small appearance for us. And that is a nice globular cluster to go after, again, because of its close proximity to Antares. Okay. And then here's a nice kind of overall field of view picture of what we just discussed. And again, it's some shameless promotion on my part. I took this one out at the McDonald Observatory a few summers back, and I took that picture, and of course, I thought it was cool to look at, but I thought it was also a great teaching tool because we can make out the teapot from this picture, as well as these different objects that we just discussed. So M4 is down here near Antares. Here you can see M7 and M6. M8 and M20 show up here. This is M8. You can certainly make that one out. And then this is kind of the location, more or less, for M16 and M17. But here they all are, all in one view. I thought that was kind of neat. And in addition to all these objects we talked about, if you're in the right dark side vicinity, if you're at our dark side or someplace else, looking at the Milky Way is always very cool to do. Now, I mentioned last week, or not last week, or rather at last month's presentation about Omega Centauri. This was one of the objects that I was able to see down in Australia. You can also see this here at home. So we don't have much time to view it, but it is available to us. So if you go out to the dark side and you find Spica, and you go down 11 degrees from Spica towards the horizon. You go down below Spica towards the horizon at about 11 degrees above the horizon at about 9 p.m. Tomorrow, this weekend. You'll be able to make this thing out. And it is a sight to behold. This is one of the early objects that I saw when I first went out to the dark side. I remember Stephen Jones had it up in his giant Dobbs telescope, and it was just unbelievably bright. As a matter of fact, it was so bright and overwhelming, I really couldn't tell what I was looking at, but it was really cool to see. So that is Omega Centauri. So put that on your list and see if you can find it. And then here is just kind of a recap of the objects that we looked at here on Sky Maps. So each of these objects is on your Sky Map. So if you make a copy of that, you can use that. And then on the second page, you will get this listing of objects that will also tell you what kind of equipment would be recommended in order to find these. So you can see we would use binoculars for M13 and M8, the open clusters, and M4, the globular. And then you're going to need telescopes. Although I would think with Albireo, you ought to be able to do that with binoculars, but certainly the rest of these you're gonna need a telescope for that. So again, this is that second page that we didn't really discuss, but it's got some really great handy information on it. So with that, I want you all to get out there and stargaze. It's going to be hopefully a clearer July than it was in June. Let's keep our fingers crossed so we can get out there and see some of these wonders of these gems, rather, of the summer sky. So let me just conclude with some quick announcements. Special interest groups are coming up. If you want the details, they're on the website. But starting next week, on the 8th, 15th, 22nd, we have visual, smart telescope, and astrophotography SIG, and then we pick back up with data science in early August. And then I don't have any information yet for the general meeting, other than it's going to be a week from tomorrow, and it will be in person, should be in person, but check the website for the details there. And I apologize for not having any details on that right now. But with that, I thank you, and I will go ahead and turn it over to you, Steve. And if there are any questions, go ahead and fire away, and I'll see what I can do.
Yes, Chris, there was one question. Just wants to know the link on where to get the sky maps again that you just showed. Yeah, that you
Yeah,
started out with.
yes,
And
I
put that in the
will.
chat. Yeah.
Yeah. Oh, you know what? That's a great idea. It's very, let me put that in the chat so you can get that. And I'll do it right now. So it's www.skymaps.com, and it's that easy. So try that. What I usually do is I will go ahead and just open up Google, type in Sky Maps, and then it takes me right there. But that's the web address, and give it a try.
Next question was, where in West Texas are you going?
Ah,
Marathon or Fort Davis?
so I'm going to go out a little bit early. I'm going to go out Wednesday and spend Wednesday night and Thursday night in Marathon. I've been driven through it, but I've never stayed there. There's a motel there that actually has like pads that you can set up your equipment on. I'm going to buy a lawn chair in Fort Stockton, and then go out there and take my Dwarf Mini and do a little astrophotography while I'm looking through the binoculars at various objects. But my understanding is that they've got power out there, and anyway, I've got an extension cord I'm going to pack in the suitcase, and then that'll be 2 nights, and then the BOV meeting is actually at the McDonald Observatory. So I'll drive back out to Fort Davis and stay there Friday and Saturday, and then come home Sunday. So that's the game plan.
And any other questions? Let me go back to this. Yeah. Uh, Somebody asked about uh, or you said something about the main meeting next week. Don Selly is running it up, and I believe it's going to be about smart telescopes.
Ah,
Yeah. And I was just getting ready to look for it, see if I can find the email.
okay. Well,
And
I'm kind of sorry I'm missing that one. And hopefully he needs to record it so I can see it.
oh, it will be. It will
Yeah.
be. Uh, I can't find his email offhand. But anyway, that's what he's planning on doing. I think he's going to chair it and just talk about the different kinds of smart telescopes.
Okay.
He sent me a neat picture. I'm trying to find it. But anyway, that's all
Okay.
I got in the
So,
chat.
so Smart Telescopes is coming up, and man, I highly encourage everybody to tune into that one. I have just become enthralled with my dwarf mini after my trip to Australia. That's kind of why I'm going out there a little bit early because, for the first time ever, I feel like I can actually go out there and do some astrophotography without, flaring up my hernia again with all of the big equipment that I've got. So it'll be kind of fun. We'll see what happens. But I think even just doing the visual out there is going to be a lot of fun too. So that's kind of got me excited.
There was one more question in the chat
Hmm.
from Cameron. Recommendations for darker sites near Katy.
Mm. Man, I think your best bet there is the HAS dark side.
Yeah,
Um,
that's what I
I
was thinking.
I can't. I mean, you can get out. You can get out west of Columbus, but then the question is, well, where do you pull over and stop? I don't know of any parks or anything out there. Plus, you're going to get all the light from the freeway. So but hey, I'm not that familiar with that part of the city. So if anybody's online that has more knowledge of Katy than I certainly do, chime in because I that's our own dark side's really the only place I've been to out there.
Yeah, for darker skies. Yeah.
You know.
Uh, J. Paul Landing, it's up in the north east or
Yes,
northwest.
Northwest.
That may be a possibility.
Yes, that is a really good that is excellent. And is it John Paul
It,
Landing
John Paul Landing Park.
Park?
I think that his name is Landing. So
Yeah.
yeah,
Let me type
and
that one in because and then you can get to that one. Um, the way you would get to that one is by driving on, or the way I went out there once, and I did the big parkway, 99, I guess, Grand Parkway,
right.
and it's right off of the Grand. You gotta once you get off of course, you want to Google Maps the thing, but it's you got a little bit of a drive after you get off the freeway, but it's easy to find. And yeah, it does have some dark skies out there. So yes.
But
That, by
also,
the way, is right around the corner from Bridgeland. Just mentioning that we
Oh,
talked about earlier. Yeah.
John Paul Landing
Yeah.
is?
Yeah.
Yeah.
It's literally 5 minutes from me.
Oh, okay. Well, there you go.
and
Seen
when you
Bill
go
out
out
there
there,
twice in the last 2 months.
yeah,
Now, have so you've been out there before,
I
Brendan?
went to the last two outreach events. Yeah, it's pretty nice. Definitely be prepared for mosquitoes. There's a lot of water out there.
How did you feel about the light pollution? Was it better than?
It's kind it's about what it is here. There aren't too many I mean there are some lights around that park there, but
Mhm.
they kind of situate their telescopes on the other side of the environmental center,
Okay.
education center, which kind of blocks quite a bit of it. But what we viewed through a 9 1/4 Cassegrain was pretty nice.
Okay.
And I think at John Paul Landing, when we do an outreach out there, they turn off the parking lot lights right next to the environmental center. So
Oh,
if you
that
just
Okay.
might
go
be
out
what they
on your
did.
own, those lights may be on.
Yeah, but that would definitely be closer. If you live in Katy, I would think that would be closer than the dark side. So that is an option. And I
Yeah,
know, again, like I know HAS routinely holds outreach out there. So anyway,
yeah. And there's some questions about what about time do they shut down? You'd probably have to call them, um,
well, if
when
you
they,
go out on
or,
I would assume if you go out on an outreach, you're going to be able to stay later than you typically would. So, but
yeah. So,
okay.
yeah, I'm
All
not sure
right.
yeah. Okay.
Are there any other questions before we adjourn for the evening? Going once, going twice. All right, well, listen, everybody. I want you all to have a happy and safe 4th of July. 250 years, quite a milestone. So, hope you're able to spend it with friends and family. And again, if you're going to be blowing off any M80s, put it on the ground, light the fuse, and get away.
And run like hell.
Don't hold it in your hand and throw it, because man, if that baby goes, you may be missing a finger or two. So,
Yeah.
anyway, I'm
Check
joking,
check
but
out
not.
check out the website for outreach events,
Oh,
the John Paul Landing um, and then the one out in League City is there. We're not going to have a memorial park for another 2 or 3 months or so, but on
okay,
the web page there's a thing, upcoming events, and you can look at that and see what's
okay,
there.
gotcha. Okay. Well, listen, everybody, again, have a happy 4th and thanks for coming in tonight and look forward to seeing you again in August. So y'all take care.